to part 2 of Competency quiz. In this video, we will answer questions relating to exponential and logarithmic functions. Of x in the expression 4 to the 4 minus x equals 1 divided by 256. Okay, we could go through the process of dealing with the log, putting both of those, applying a log to both sides. However, we could also do this. We could use our numeric solver. So push math and arrow up till you get C, numeric solver. Push enter. Then type in each side of the equation as we've done before. So let's clear this out and say 4 carried up. 4 minus x. Oh, I hit the wrong thing. Sorry about that. Let's go back to math, go up and enter, and it is still there. Okay, that's one good thing. All right, so we go to x. Now arrow down, clear out, and this will be the right side of our function, which is just 1 divided by the 256. Okay, now we push OK, which is the graph button. We may have to push it twice. So graph, and no, it's there already. And the value is 8. Okay, so the option that we need is A, which is 8. Okay, now applying the log, that'll take us a little more time. But on the left side, if we apply the log, we have 4 minus x, and then that would be the, I'm going to use natural log of 4, okay, and that will be equal to the natural log of 1 over 256. Okay, so then what do? We divide both sides by the natural log of 4. Okay, all right. All right, then of course, natural log of 4 over natural log of 4 cancels out. Then what do? Well, we have a few things going on here, but we know that we need to subtract 4 from both sides. So we subtract 4. Then this cancels out. But we need to notice that we have a negative x on the left-hand side. So if we multiply both sides by negative 1, we'll get a positive. So multiply both sides by negative 1. Well, that is give us x equals. Then we just put this negative in front and just copy down everything and enter it as we see it. Okay? All right, and that'll be 1 over 256. Okay, and we can just put that in the calculator as is, and we should get the precisely the same answer, actually. Okay, so let's back out of that, and let's use our parentheses correctly. All right, so I'm going to put negative and my parentheses, but I'm going to say alpha window, arrow over. Number 1 is what I need. Okay, now I'll say the natural log, 1 divided by 256, then arrow down. Oh, okay, there it is. Got to be careful what we push. I think I arrowed down the wrong way. Okay, so now I need the natural log of 4, arrow over, close my parentheses, and then minus 4, and push enter, and, oh, I see what I did. It was, okay, you may have seen it too. If I'm going to say negative, I have to say negative of everything. And in that case, what I did up here, we can bring this down and enter again. What will happen is this negative, in the way I put it in, would become a positive 4. Okay, now let's push enter. Now it's correct. Okay, so I would have had, the way I had it written, we would have needed a double parentheses. But the way I entered it in the calculator, we simply need to make this a plus. So if you see what was going on, I really needed to distribute that negative to both terms on the right side, and I didn't do that. I did it in the I didn't do it in the calculator, and I didn't do it when I wrote it down, which is not correct. Okay, but now we fixed it and we have the same thing. And we had already had the numeric solver that told us what to do, what the correct answer was. Okay, so let's look at number 7. Okay, which one of the following statements is correct regarding the graph of y equals ax when x is greater than 2 and a is not, greater than, a is greater than 0 and a is not equal to 1. And the reason I said 2 is because this is what I had in my head. If it's going to be greater than 0 and it can't be 1, then let's make a equal to 2. And this would imply that we could say y equals, I'm not sure what's going on. Okay, y equals 2x. Okay, so let's put that in our calculator. All right, let's push y equals, clear out anything we have in there, just so we only have one graph showing. We could turn off others, but we're not going to. Okay, so we have 2, carry it up, put in your x, and push graph. And there we go. Oh, I need to change the color of my graph because my axes are blue. So let's make it a nice yellow or something. Let's push enter. And oh, there we go. Just I arrowed once to the right. I just arrow back and forth until I find a color I like. To be honest, honestly, that's what I do. Okay, so let's arrow down to our OK. Push enter. Now let's graph it. And we have a nice bright yellow we can really see. And you could probably see that it goes through a 0 and 1 coordinate, if you see that. Okay, so let's look at this. Now we have a reference. We have something that we can look at as we read through our options. Okay, A, the domain and range are all real numbers. Is the range all real numbers? No, it is not. So the domain is all real numbers, but the range is not. So let's go to B then. The domain is all real numbers. We agreed already on that. And the range is all positive numbers. I agree with that because if you zoom in, you will see that it's never equal to 0. It's always above 0. So I'm going to say yes on both of those. Let's keep reading. C, the domain and range are all non-negative numbers. The domain is on the negative side or the left side of the y-axis. See, so it has to be some negative numbers. So we've already agreed that it's all real numbers. It can't be one or the other. It has to be negative and positive. So I'm going to have to disagree with that statement, all of that statement. D, the domain is all non-negative numbers. No, I disagree with that part. And the range is all real numbers. And I disagree with that. That entire statement is incorrect. So we know now that the correct option is B. Okay, let's look at number 8. Given f of x equals log of 5x, the argument's x, that is, and that g of x represents the reflection of f of x across the line y equals x, which one of the following is the explicit representation of g of x? Okay, here is a rule that I haven't introduced and you may or may not know. Y equals x is your identity line, okay? So let's put f of x into the calculator and let's put in our identity. And then I will discuss the rule with you. Okay, so let's go back to the y. All right, let's clear this out. And let's put in Oh no, we can't put that in. Yeah, we would have to put that in differently. Okay, now let's see, log. Okay, there's a couple ways we can put this in. Okay, let's think about this. Okay, so what we're going to do is we're going to use the alpha window option. Alpha window, and we can go to number 5. So let's push 5. All right, and that gives us, well, and push 5 again because that's obviously the base we need. And then arrow over, and let's put in our X. There is another way to put that in, and we can do that right below it to see what we have. But let's not do that yet. Okay, so let's use our Y equals X. So just push X. Now let's graph this as is. Okay, you see what's going on. Okay, you have the bottom part where it's reflected. So we need the part that reflects over to the top. Okay, right? If this should be familiar to you at this point. Okay, so the rule is, all right, let me get a different color. This 5x, that is actually the reflection. So that reflection should be 5 to the x, okay? Which is option A. But don't just believe it. Let's check it visually, okay? Yeah, don't believe everything. And sometimes I think I am correct, and then I give it a moment and I think, okay, well, let me try something to double check what I'm doing right now, no matter how sure I am. Oh, no, that did it. Okay, let's carry it up and go to X and graph it. Okay, what color is our graph? Oh, that's why. Look at what color it is. It's black. No wonder we couldn't see it. It also helps to put the right colors in. Okay, let's push enter then. I have it highlighted. You notice I highlighted. I went over and highlighted. Black is not a good color on a black screen. Let's use that red. Okay, so let's go down. Let's use red. All right, go to OK and enter. And now let's graph. There we go. That looks very nice. And if you can see, it is a true reflection. It's a little bit off because we don't have our screen squared. We could try a different one. Let's try zoom, and we have it on standard. Let's use number 5. See where it says z squared? Let's see if that's any better. Oh, there, yeah, it actually is really is better. It squared it up for us. Okay, that looks good. All right, so it is option A. Now, what I was talking about before is, let's see if this will work here. There is another way to enter that log 5x, okay? So we can push log and then 5. Oh, no, it'll be x, I'm sorry. X is first. Okay, so it's x, log x, and then you go over, push divide, and then log of the 5. And then now let's graph that and see if it works. See what happened? It's exactly the same. The pink one on top. Let's go back to our y equals and look again. Okay, this is the one that I changed. See, it's pink. So that color, so let's make it a different color so you can really see it. So it should go over the yellow. So you should see yellow and then another color on top. So let's make it, oh, how about that orange? Okay, let's push enter and let's see if we can, that orange is bright. I'm not sure where that orange is, but I will try it. I know it's here somewhere. Oh, there it is. Okay, let's go down. Oops, that's what happens when you go down too much. Okay, let's push the X. Okay, there it is. Now let's graph. Did you see it? It went right on top of it really fast. So that tells you there's 2 ways to enter it. There's one where you have it already done for you, and then that's another way to put in logs. Use the equation below to solve the following. Number 9. The energy released by a certain earthquake is 10 to the 8 joules. What is the measurement on the Richter scale using 10 to the 4.4 as the value of E naught, which is the initial value? Well, we have everything we need. All we're doing at this point is plug and play. So let's plug that into our calculator. So we have parentheses alpha y equals, push enter because that's our fraction we need. So we have 2 over 3. Arrow over, close parentheses, open parentheses, push log. And now let's set up a fraction again with the alpha y equals. Now we have our e. That is our given here, 8 to the 10 joules, okay? Right here. 10 to the 8 joules. Sorry about that. Read it backwards. Okay, 10, caret up 8. Now arrow down. Now our E naught is given as 10, caret up 4.4. And yes, I'm going to enter the 0 just for accuracy. Arrow all the way over, parentheses, parentheses, and I do that because I like being thorough and as accurate as I can be. So now let's push enter, and 2.4 is precisely what we need, okay? All right, now let's talk about number 10. We also need to talk about the change in my calculator. Okay, I updated in the middle of this video, so my buttons are big, but at least you can see them. So I am going to clear out my history. You can always, as I do this throughout videos, you can always rewind and look at what I've pushed. That's part of the reason why you use the emulator so your student can see what to push, okay? All right, now, number 10. If the number of decibels associated with heavy vehicular traffic is 89.3, what is the sound intensity in watts per square meter using 10 to the negative 12 as the value of I naught? Okay, well, D is the decibel. This is also an equation we used in a prior video, okay? And I is intensity, we have I naught. However, we don't have everything we need here. So this is not a plug and play exactly. What we have as a setup is we're given the 89.3 decibels and we know 10. And then we know that we're going to use log of I intensity because that's what it's asking. What is the sound intensity? Okay. And then I naught is given to us as 10 to the negative 12. Okay. Well, we can use our solver for this. If we understand that I is equal to X. Okay. So let's push math, arrow up. We need C, that's our solver. Now, I already have it entered. Let's verify that I have that 89.3. Okay, and then below that, the E1 I always put in as the left side of the equation, and then on the right side is my E2. So 10, my log is entered correctly, and I like to complete my parentheses, so let's push OK. Now, this could have been a prior question. So always push graph again because it says solve. This means you haven't technically solved it. So push graph again. Now, when we see the E1 minus the E2 equals 0, then we know we've actually solved. And yes, that is our value that we need. However, we need to do some eliminating here. Looks like A is out and B is out. Well, this is in scientific notation, and my answer is given in scientific notation, but a rounded notation. So they have rounded to 8.5 to begin with. Well, C and D have that. But here on the end, the e minus 4, negative 4, that's what we need. That means you have 10 to the negative 4. So that eliminates C because it's 10 to the negative 3 and leaves us with D. Okay, this is the very last question in this video, and there will be many more videos to come. Thank you for your kind words and your liking and your sharing. And those of you who have subscribed, you are phenomenal. I wish everyone the best and happy testing, everyone.